Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 3.5, Problem 19. This is Section 3.5, Problem 19. It says Steve is 70 inches tall. If there are 39.37 inches in a meter, how tall is Steve in meters? And at the end it says round your answer to the nearest hundredth. So what we have to do is divide, right? And why am I dividing? If Steve, say a meter is almost 40 inches. If Steve was 40 inches tall, he'd be 1 meter tall. If he was 80 inches tall, he'd be about 2 meters tall, right? And how am I getting that? The 40 divides into 80 twice. So what I have to do is divide the 39.37 into 70, the 70 inches that's Steve's height. Now, if you had a calculator, the way you would write this is you enter the 70 first, which you call the dividend, then divide by 39.37. So if you're curious at the end of the problem, you want to get your own height in meters, and you can use a calculator, you'd enter it that way. To do it by hand, though, you want to write the 70 under the division symbol and put the 39.7 in front. Now, to start the problem going, the number in front of the division symbol, you can't leave the decimal point between the 9 and the 3. It has to be pushed as far to the right as it will go, which means it has to move over 2 spaces. Now, you can move it as many spaces as you want, as long as you move it the same number of spaces for the number under the division symbol, the 70. 70 has no decimal written. So you can assume that the decimal is at the end of the 70. Now, if you move it 2 places, I have to fill in 2 zeros to hold those places. It comes over 1, 2 spots. So you move it 2 places to the right for the number in front of the division symbol, and that means it also has to move 2 places to the right for the number under the division symbol. So to do it by hand, the division that has to occur really is 3937. So 3,937 divided into 7,000. And that will give us Steve's height in meters. So, again, it's only really going to fit in once, because if I do times 2, it would be almost 8,000. 2 is too big. So 1 times 3,937 is 3,937. And I have to subtract 7,000 minus 3,937. They're fairly big numbers. You're going to have to borrow for this unless you're really good at subtraction. So 0 minus 7, the 0 is not big enough. So move over 1 spot to the left, another 0 is still not big enough, another 0 to the left, still not big enough. To start the borrowing process, you have to go all the way over to the 7, all the way to the left because you have so many zeros. Borrow from the 7, so it's going to make it a 6. Now the next 0 to the right, you can make it a 10. Borrow immediately, reducing it to a 9. Then when you borrow, you can make the next 0 over into a 10. Borrow immediately, make that a 9. Then the last rightmost 0 can be written as a 10. Now you can start subtracting. So 10 minus 7 is 3. 9 minus 3 is 6. 9 minus 9 is 0. 6 minus 3 is 3. So I have 3,063, which is smaller than the number I'm dividing by, so it's okay. Now, what you want to do is move over 1 position to the right and bring down the next digit. There is no next digit, but I'm not done. It didn't fit perfectly. So what do? Well, what you can do is just the decimal point that I moved is at the end. You can write a 0 in. It's in there. You just don't usually bother to write it. And now you can bring it straight down. So how many times will 3,937 fit into 30,630? That's too big to estimate. Enough trial and error, you'll eventually get it. Round off the number a little bit. This is almost 4,000. This is a little bit more than 30,000. So just really 4 into 30. 4 times 7 is 28. So 4 times 4,000 would be 28,000. That gets you pretty close. If I go another from 7 up to 8, it'd be too big. 8 times 4 is 32, so 32,000, too big. I've gotten too big. So 7 will do it. 7 times 7 is 49. Write the 9, carry the 4. 7 times 3 is 21, plus the 4 that I carried. 21 and 4 is 25. Write the 5, carry the 2. 7 times 9 is 63. 63 and 2 more is 65, right? The 5 carry the 6. 7 times 3 is 21. 21 plus the 6 that I carried is 27. So it fits pretty good. So now I have to subtract 30,630 minus 27,559. Again, I'm going to have to borrow. The 0 minus 9 won't work. So borrow from the 3, make it a 2. And then I can write the 0 as a 10. 10 minus 9 is 1. 2 minus 5, that won't work either. The 5 is too big to subtract from the 2. Go over to the next spot, borrow that 6, make it a 5. And then you can write the 2 as a 12. 12 minus 5 is 7. Then 5 minus 5 is 0. Then I can really think of this as 30 minus 27 is 3. So I have 3071. So it works. So now I'm not done. It didn't fit in evenly. Again, I have no digit further to the right to bring down, but I can just put in a 0. Again, it's there, really. We just don't bother to write it. So now I can bring that 0 straight down. And again, I have something a little bit bigger than 30,000. Not much. So 7 will work again. Because for 30,600, 7 was good. So for 30,700, 7 is going to be good again. And since I already did the multiplication, I can figure it out again. But it's going to come out to the same number. 27,559. Now, the result for the subtraction will be different. Now, this is to the nearest hundredth. When I bring my decimal straight up, I have 1.77. The question is the next digit over. Well, the next digit over, when I do this problem a little bit further, will it be 0 through 4, which means I'll stop at a 1.77, or will the next digit over be 5 through 9? If that's the case, my answer to the nearest hundredth will be 1.78. So I do have to go a little bit more. So do the subtraction, and again, I can't use my previous answer. The bottom number is the same, but the top is different. So again, 0 minus 9, 9's too big. So borrow from the 1, make it a 0. That 0, the rightmost 0, can be written as a 10. So 10 minus 9 is 1. The next column, 0 minus 5. 5's too big, I can't subtract. So go over one column, I have a 7. Borrow from the 7, make it a 6. What I had as a 0 can now be written as a 10. 10 minus 5, that works, that's 5. 6 minus 5 is 1. 0 minus 7 won't go. 7's too big to subtract from 0. So go over one digit over, cross off the 3, make it a 2. That 0 can be turned into a 10. So I have 10 minus 7 is 3. So I have 3151. Which is smaller than 3937, so that's good. So it is 1.77. Now, again, it didn't go in evenly. I want to know what happens one more digit out. So figure that I have a 0. Again, it's actually there. We just don't bother to write it. Bring it straight down. So I want 3937 going into 31,510. And based on my answers from before, I can see I'm getting another 7. I'm getting more 7s. And at this point, I don't care what happens after. The question says rounded to the nearest hundredth. So the hundredth position is 2 places to the right of the decimal place. So now, right now, it's a 7. If I go out one more digit to the right, it's big enough when it says round it that it's going to be 1.78. So I can stop there. Even though it doesn't finish, it might go on forever before it goes in evenly. I have 1.78. Now, because this is an application problem and it involves units of measure, I can't just leave a number. I can't say 1.78. The question was, how tall is this guy Steve in meters? Right there. So the answer is 1.78 meters. If Steve is 70 inches tall, that means he's 1.78 meters tall also.